We are asked to determine whether the given series converges or diverges, and if it converges, we are asked to find its sum. Let's first notice that the series is a sum of two series, like so. Now we notice that both of these series are geometric. Why is that? Let's rewrite them more conveniently and use the associated theorem. Let's start with the first series. In this case, we notice that our k, this constant coefficient, is the square root of 2. And we also notice that our power is n minus 2, and that in fact the series starts at n is equal to 2. What we want to achieve is rewrite it so that it starts at n is equal to 0, and that's an easy shift. Similarly, in the second series, we notice that our k is somewhat hidden, and the way we find it is by first writing 2 to the n as 2 to the 2 times 2 to the n minus 2 to liken it to the term in the denominator. Now we can readily perform the shift so that this series starts at n is equal to 0. Looking at our theorem, we will first identify x in both of these series in order to decide whether it converges or not. In the first series, x is equal to 1 over the square root of 5. And this is indeed smaller than 1 and also larger than -1. And so we are assured that this series converges. Similarly, in our second series, x is equal to 2 over root 5, and that is also bounded above by 1 and below by -1. So this series also converges. And the theorem tells us what these series sum to, namely the square root of 2, which is our k for the first series, divided by 1 minus the x, which is 1 over the square root of 5. Perhaps we want to multiply through by the square root of 5 to get rid of the fraction within the fraction. And so this becomes the square root of 10 over the square root of 5 minus 1. For the second series, we have 2 squared, which is 4, as our k, divided by 1 minus 2 over square root of 5. And here we also multiply through by the square root of 5 in order to get rid of the fraction within the fraction. So our series converges, and it sums to the addition of the two sums that we've just written down.